Greetings, class. This is Dr. York-Hammons. I'm looking at some problems from the study plan for Chapter 3, Section 4. It seems like once everyone got through the contingency tables using the complements, that some more problems arose in Section 4 with permutations and combinations and being able to actually calculate those. When you take your next exam, the calculator that comes with MML doesn't have permutations and combinations. And unless you have one of the approved calculators, a TI-83 plus, TI-84 plus, or a TI-Nspire that can be set for the testing site, you'll need to use the calculator in StatCrunch to do those because they do get rather difficult as you go through. So let's go ahead and look at a sample problem. I'm going to start, let's look at this 3.4.7. And I'm going to see if I can get it to not be so big. It says to evaluate the given expression and express the result using the usual format for writing numbers, but not scientific notation. So they're saying if it's extremely large, you're just going to put a lot of zeros at the end of it, rather than use a power of 10. So we have a P, which means a permutation of 42 objects taken 2 at a time. And we want to know how many possible ways can that be done. If you're in StatCrunch, in order to do this calculation, you go to Data, you go to Compute, and then Compute an expression. Now, we've done this before. We've built expressions. The only difference is you have to look for permutation, which will be in the P's. And it's under the name perm. So I double click the PERM for permutation, and there's a parentheses with a space before the comma and one after. The space before is your in objects. So this is 42. And then I'm going to arrow past the comma and tell it how many of those objects I want to take at a time. And my this is N is 42, R is 2. So that's my R that goes here, 2. And so I say, okay. And I'm going to call that question 3.4.7 so that I won't have my data end up in the gray row. So when I compute, it says it's added a new column. So for question 3.4.7, my answer is 1722. Let's check that answer and see if we got the right thing. It says, nice work. Next question. So let's see what our next question is. So this one is a combination. So we have N equal 28. So 28 objects in our set, and we want to take them in groups of 3 of them at a time. So again, you do the same thing in StatCrunch. You go to Data, go to Compute an expression, and build it. But this time, instead of permutation, you want combination. So you see the COMB, that is combination. You double click and you get COMB with the parentheses, with a comma to separate the N and the R for your combination. So I do 28, or you can use your keyboard to type that in. I think that's what I did in the last example. Then I'm going to arrow over. I'm using my keyboard to arrow over, and then I'm just going to type the number 3 on my keyboard, and I'm going to click OK. And this is question, I may have to scoot this over a little bit so you can see that they really are, question 3.4.10. So my column label is going to be 3.4.10, and I'm just going to click Compute, and I'll hide my table. So the answer to question 3.4.10 is 3,276 possible ways to arrange 28 objects in groups of 3 or using 3 of them at a time. So I wouldn't be using all of those objects. It's like you might have 28 photos, but you only have 3 frames in a setting, and you want to rotate those pictures in and out. You would have 3,276 different possible ways to do that if you didn't care what order the pictures were inside that 3-frame setting. So let's check our answer and make sure I'm right. Okay, looks like we've got another question. Looks like we have 35 of these here. Now this one's division, but you can still do this same problem in StatCrunch. You're just going to have to use a division sign between the two. Let's see if we can do that. So we're going to go to Data, Compute Expression. Now our expression is going to build 2 combinations. The first combination is 9 objects taken 4 at a time. N is 9. R is 4. So let's do a combination of 9 things, arrow over, 4 at a time. Now I'm hoping that I can arrow out of that and use divide and then do combination again. This time I've got 11 objects taken 4 at a time. So let's do 11, arrow over, and 4. So you see the 11 and the 4, and that's this division of that combination. And this is question 3.4.11. So I'm going to compute. And let's see if, it says round to the nearest thousandth. So that's 3 decimal places. I have a 3, a 8, and a 1. If I look to the right, there is an 8. So that 8 is going to cause this 1 to go up to a 2. So I have 0.382. You don't have to put the 0 in front unless you just want to. Oh, fantastic. Next question. Let's see what we've got next. I'm going to this one's a permutation, but it's division as well. So let's just practice one more time with StatCrunch. We go to Data, Compute, Expression. We're going to build an expression. This time I don't want combinations. I've got to scroll down to the P's. Don't type a P or it'll put a P up in your expression row. But you need PERM, so it looks like I've gone too far. PERM, permutation, double click. The first one is 6 objects taken 3 at a time, and order is important. So 6, arrow over and put a 3, arrow out of the parentheses, and we're going to divide, that's our fraction for this division over here, and we're going to divide it by another permutation, so I double click. And this permutation is going to take 10 objects, has 10 objects that are being taken 4 at a time. So that's 10, arrow past the comma, and put a 4, and then arrow outside of the parentheses and click OK. And this column label is going to be 3.4.13. So you can see that I can show work. I'll go ahead and do this before I keep talking about that. But you can see that we can show work for every question in an exam in one StatCrunch file. So I'm going to type this, round to 4 decimal places. So I have the 0, the 2, the 3, the 8. And then on the other side of that, I have a 0. So this 8 stays the same. Now that 0 right there after the decimal, I must type in. So I can put my decimal 0, 2, 3, 8. And hopefully that is the correct answer. Oh, all right. Wonderful. Next question. So the next ones you see are about deciding if you need a permutation combination or neither. So it says the number of ways a 4-member committee can be chosen from 15 people. Now, since it doesn't matter, it's not like I'm doing the president, vice president, secretary, and treasurer. They didn't tell me what offices. I just need a committee. So this would be a combination, and the order of the committee members would not matter. Oh, and now we're going on. I thought we were going to do a calculation. I'm sorry. I'm going to pause this, and I'll come back to you as soon as I have one involving a calculation. I found one that asks us to do a particular calculation. It says you have 11 different video games. How many different ways can you arrange the games side by side on a shelf? Now, it doesn't matter what order they're in. It's not like you're putting them by genre, science fiction and biographies and romance novel, romantic comedies or something. You're just putting them on the shelf. And so when we do something like this and we're using all of them, it's not like we need to do a combination or a permutation. I just need to know what 11 factorial is. And you can do that in StatCrunch as well. So data, compute, expression, and when we go into the expression and build it, we need factorial. Well, they don't have the word factorial, but they do have the word fact. And if I double click fact, it gives me a parenthesis. I have 11 games, so I'm just going to type 11 in and arrow out. So I'm going to get 11 factorial. It's going to put OK, and I'm going to label the problem 3.4.19 and then compute. And so for question 3.4.19, oh my goodness, there are 399,168,00. So that looks like, if I look at that, that's like 39,916,800 different ways to arrange those games. Let's check that. Boy, that sounds like a lot. That's right. So over 39 million different ways that you could arrange those games. You'd spend the rest of your life checking to see that you'd use every possible arrangement of those 11 different video games. That's just crazy.